So this is National 4, National 5 Chemistry, and our topic for today is carboxylic acids. Now, carboxylic acids are another example of a homologous series, and they can be identified by the carboxyl functional group, which if we're writing it as part of the molecular formula, we would write it as COOH or Q. But if we were to draw it in a structural formula, it is a carbon atom that has a double bond to an oxygen and a single bond to a hydroxyl group. So carbon has one double bond to an oxygen, then a single bond to an oxygen, and that is bonded to a hydrogen. And you can see that there's one bond left on the carbon, and that bonds to other carbon atoms. Or sometimes a hydrogen. Now, the carboxyl functional group must always be at the end of a carbon chain. So it's always at the end. Each member of the carboxylic acids has a name which ends in anoic acid, and it would have a prefix indicating the number of carbon atoms. So the diagram shown is ethanoic acid, and that's because the carbon that is part of the COOH group is always carbon number 1, and if we count across, we've got a second carbon. So that is ethanoic acid. Now, the general formula for carboxylic acids is very similar to the general formula for alcohols. It is CnH2n plus 1, and then we have COOH, or a Q in the chain. So when it comes to naming carboxylic acids, we use the same prefixes as we have for alkanes, alkenes, and alcohols, meth, eth, prop, etc. Now, methanoic acid, the only carbon in methanoic acid is in the functional group itself, and then there is just a hydrogen bonded to it, and it is HCOOH. Ethanoic acid is CH3COOH. And ethanoic acid, that is the acid inside vinegar. So now you know that vinegar is a carboxylic acid called ethanoic acid. And propanoic acid contains 1, 2, 3 carbons. It is CH3CH2COOH, or C2H5COOH. Now, when it comes to naming carboxylic acids, we always count the number of carbon atoms in the longest chain with the functional group present. Remember that the carboxylic acid functional group is always at the end of the chain, so it's always going to be on carbon number 1. So we don't need to use a number to tell ourselves where the carboxylic acid is on the chain, because it's always on carbon number 1. And then we count the rest of the molecule to see how many carbons there are and use the appropriate prefix. Remember that when you're counting the carbons, the carbon that is part of the COOH group is always carbon number 1. Now, the uses of carboxylic acids. Well, carboxylic acids are used in the preparation of preservatives. Vinegar is a preservative in itself for pickling things, but carboxylic acids can also be used to prepare soap. And carboxylic acids are important in lots of medicines. So definitely aspirin contains a carboxylic acid. Carboxylic acids can also be used as cleaning products. Now, examples of carboxylic acids, so one that I've said before, is vinegar. So vinegar is ethanoic acid, sometimes called acetic acid. and it has the molecular formula CH3COOH. Vinegar, or ethanoic acid, can also be used as a cleaning product because it's non-toxic and is safe to use in the house. And vinegar is particularly good at cleaning glass and mirrors, and is also good for where you get a build-up of lime scale. So bathrooms and kettles and things like that can be cleaned well with vinegar. Now again, like alcohols, methanoic, ethanoic and propanoic acid are all miscible in water. That means that they dissolve, but as the length of the chain increases, the number of carbons increases, the solubility decreases. So a trend is that as the molecule gets bigger, the harder it is to dissolve. Similarly, like alcohols, as the size of the molecule increases, the melting and boiling points also increases. And again, this is due to the strength of the molecular or the intermolecular forces, something which you will learn about in higher chemistry. So all you need to know is the trend. As the number of carbons increases, the melting and boiling point increases. You don't need to know why. Now, they are carboxylic acids. So what do you think the pH of these molecules would be? Well, carboxylic acids are acids. So they have a pH of less than 7. And they typically would turn universal indicator red or orange in color. They also react just like any other acid. So you can react metal oxides, metal hydroxides, and metal carbonates with carboxylic acids. But how would you name the salts produced? Well, it's quite straightforward. The salt produced depends on the carboxylic acid, which is used in the neutralization reaction. But if you use methanoic acid, you produce methanoate. So for example, sodium hydroxide plus methanoic acid produces sodium methanoate plus water. Ethanoic acid would produce sodium ethanoate. So all you're changing is the IC to an ATE. Ethanoic, ethanoate. Propanoic, propanoate. Butanoic, butanoate. Pentanoic, pentanoate. Hexanoic, hexanoate. Heptanoic, heptanoate. Octanoic, octanoate. So it's most common for them to use ethanoic acid, as it's the most common carboxylic acid used in reactions. And they produce ethanoates. And here's an example. So we have methanoic acid plus sodium hydroxide. Remember, carboxylic acid plus alkali goes to salt plus water. So methanoic acid plus sodium hydroxide gives us sodium methanoate plus water. Ethanoic acid plus potassium hydroxide would give us potassium ethanoate plus water. So that has been our introduction to carboxylic acids. We learnt about the carboxyl functional group, the COOH group. We learnt how to name carboxylic acids, and we know that a carboxylic acid must always appear at the end of a chain, so it's always on carbon number 1. We learnt some of the uses of carboxylic acids. We learnt how to name carboxylic acids. And finally, we learnt the reactivity of carboxylic acids. And we learnt that they react with alkalis in the same way that other acids do. And the name of the salt, all you do is you take the name of the acid and you change it from example methanoic to methanoate. And our next lesson will look more at some of the properties of hydrocarbons in general.